Welcome to the 7th grade podcast. This is Mr. Gornto. Today we're going to talk about Newton's laws of motion. This is going to help you be ready for your test on Tuesday. The first law is pretty simple. It talks about, it's often called the law of inertia. It says that an object at rest is going to remain at rest, and an object in motion will remain in motion at a constant speed and in a straight line unless acted upon by an unbalanced force. This is a lot of words for something really simple. It basically just says that an object is not going to move unless something moves it, and it's going to continue to move until something stops it. So if we have the ground here and you've got a ball on the ground, that ball is going to sit on the ground and it's not going to move until something moves it. Nothing's going to happen. A force is going to have to come along. That's that unbalanced force that's talked about in the law. Now, if I come along and I kick that ball, and suddenly this ball starts to move in this direction, I'm the unbalanced force that's kicked the ball, and the ball is going to continue to move in a straight line at a constant speed until something acts upon it to stop it. The something that's going to act upon it to stop it is going to be friction. Friction's a force that opposes motion, so as the ball continues to roll, it's eventually going to slow and then come to a stop. That's all this whole first law says. And that's what this term inertia is really talking about. It's a tendency of all objects to resist change in motion. It means once it starts in motion, it doesn't want to stop. Once it stops motion, it doesn't want to get going again. That's all the first law talks about. One of the examples we gave is if I'm playing tennis, for that tennis ball to make it over the net, I have to pick it up and hit it over the net. It doesn't just, if I set the ball on the ground, it doesn't just hop up and jump over the net. I have to pick it up and hit it. Therefore, I'm the unbalanced force that's putting the ball into motion. And it's going to remain in motion until an unbalanced force changes that, such as gravity, which makes it go to the ground, or the person I'm playing against who hits the ball and serves it back to me. Now, the second law talks about the acceleration of an object depends on the mass of the object and the amount of force applied. You'll often see this equation, F equals m times a. That means force equals mass times acceleration. In other words, when I hit that tennis ball, the harder I hit the ball, the more force I apply to it, the more acceleration the ball is going to have going over the net. Now, we've used that example over and over and over again because a tennis ball is going to remain the same mass. So that kind of took the mass part, but I think some of you kind of got confused by us not mentioning the mass part. So let's put mass back in. We go to the grocery store and we're pushing a grocery cart around the grocery store. And we want to stay at the same speed. We want to keep moving at about, we'll say 2 meters per second. So as we move 2 meters per second, that's a nice brisk pace as we're moving around the grocery store. It's going to be easier to move around with an empty cart than when. So as we fill the cart, we have to apply more force on the cart to be able to continue moving at the same speed. Because remember, we said we wanted to continue moving around the grocery store at the same pace. We moved at, I think we said 2 meters per second. So as we add groceries to it, the cart has more mass to it. So as it has more mass, we have to apply more force to continue moving at the same rate of acceleration. That's the second law. So, like I said, we said that when we hit a tennis ball, the harder I hit it, the more force I apply, the more acceleration. So we've kind of tied that force and acceleration, but you can't forget about that mass part. So remember, if the mass is changing, the more force is going to be required. So, it's kind of like the difference between if you take one of the smaller 7th graders that we have and put them in my chair and try to roll them across the room, you're going to have to apply less force than you would rolling me across the room at the same rate of acceleration. That's the whole idea of that second law, force equals mass times acceleration. Now, Newton's third law is often called the action and reaction, or forces act in pairs. And basically it just says, when an object exerts a force on one another, the second object exerts a force equal and opposite. So that just means that when I'm playing tennis and I hit that ball, my racket's applying a force on the ball, but the ball's applying an equal and opposite reaction to my racket. I think I told you in class before that if I held the racket really loose, that racket would fall out of my hand when that ball hits it because of the force that they're applying to one another. you have two cars coming together, or two grocery carts. Let's say we're grocery shopping and we're pushing the grocery cart around, and we turn the corner and another person turns the corner coming our way, and we hit grocery carts together. The force that my grocery cart applies to the grocery cart that I hit, well, their grocery cart's applying an equal and opposite force to mine. Guys, that's about all there is to Newton's laws of motion. If you have any trouble with it, listen to this again. Take a look at your notes. Look at your quiz for it. And if you're still having a problem, make sure you see me. Have a great day and get ready for your test on Tuesday.